Okay, let's have a look at the paragraph about levers. Question 38. Lisette, who weighs 26 kilogram, and her mother are sitting on a seesaw. In the situation in the illustration, the seesaw is balanced. Calculate, and then we have to do 3 things, so they do it step by step. First they say calculate the force of gravity on Lisette. Let's start with writing down the data. So we know that M equals 26 kilogram, and we have to calculate the force of gravity. So we want to know Fg. Now that will be in Newton. What else do we know? Yeah, we know G is 9.8 Newton per kilogram. The formula that we have to use here is Fg equals M times G. So Fg equals 26 kilogram times 9.8 Newton per kilogram. So Fg equals 26 times 9.8, 254.8, 254.8. But what will happen with the units? We have kilogram, and we multiply that by Newton per kilogram. So we have Newton divided per kilogram, and we multiply that by kilogram. Now, if we divide Newton by a kilogram, but we also multiply it by a kilogram, now that's a bit useless. So we end up with Newton. Now look at the number of significant figures. I would say this is 255 Newton. So what are the steps? 5 steps. This is our data. This is what we have to do. This is also part of data. This is our formula. These are the workings. And here we have the answer. Okay, so that was the force of gravity on Lisette. Now we have to calculate the force of gravity on Annette. And now we have to use the law of levers. Okay. So what is the data? We know F. What's always easy to do is take the drawing, and then under the drawing we write down the data. So we have here Lisette and the mother Annette here. Now we know F on this side. On the left side I will always call it 1. On the right side we call 2. There is a distance to the fulcrum. Now this is the fulcrum. So Lisette is sitting 1.5 meters away from the fulcrum. We use R radius for that. So we can say it's 1.5 meters. Her force of gravity we know, we just calculated that, 254.8 Newton. Force 2, so the force of gravity of Annette, that's what we have to know, so we don't know that one. But we know that she is sitting 0.45 meters away from the fulcrum. So this is the data. This is what we need to know to start solving this this question. So what we need to know now is the formula. Now the formula, they say already use the law of levers. So that is F1 times R1 is the same as F2 times R2. The one that we have to find is F2, so we want to rewrite this formula as F2 equals, now that equals 1 for F1 times R1 divided by R2. And we can fill in the data. F1 is 254.8 Newton. R1 is 1.5 meters. And that's all divided by 0.45 meters. So, 254.8 times 1.5, that is 382.2. Newton times meters, that is Newton meter, and that divided by 0.45 meters. That is 849.33333. So we can say F Z, Annette equals 849 Newton. Now, what is important that we always have the right force, the right arm. So make sure when you look at the picture that you know, okay, her force of gravity goes with the 1.50 meters, and her force goes together with the 0.45. Now, if you do that right, there's nothing you can do wrong. Now, question C is calculate Annette's mass. Now we know. So we know our FZ. We know FZ, we know G, and we want to know mass in kilogram. We know FZ equals M times G. We want to know M. So M equals FZ over G. So that is 849 Newton divided by 9.8 Newton per kilogram. So we have this one still in the calculator. So 849 divided by 9.8, and that equals 86.666. Let's have a look at the units. We divide Newton by Newton per kilogram. So we divide by a fraction. Dividing by a fraction is the same as multiplying by the inverse. So this is the same as Newton times kilograms over Newton. So we divide by Newton and we multiply by Newton, so that is kilograms. And that's exactly what we're looking for, because we want to have the mass. So mass is 86.67 kilograms. Now that is 87 kilograms. what do you see here? We started with converting the mass into gravity or into a force, and we ended with doing the opposite. I think we can do that faster. Let's have a look at 39. At 39, we have to find out the mass of a fish. We can ignore the mass of the stick. So what do we have to know? This side is 20 grams on a distance of 20 centimeters, 40 centimeters. Here the distance, and we have to know the mass. Now, let's have a look at the formulas that we are using, because we can have a little shortcut here. We've learned the formula. The moment on one side has to be the same as the moment on the other side. And we know that the moment is the force times the radius. And we know that the force is the mass times g. We can substitute the first formula, the second one in the first, and that will be then force 1 times radius 1 equals the force 2 times radius 2. And instead of force, we can also use m times g. So we can say m on the left side times g on earth times r on the left side equals m2 times g on earth times r2. Now you can see that g is the same on the left side as it is on the right side, because it's both the 9.8 Newton per kilogram. So what we can do, we can divide both sides by g, and we have m1 times r1 is m2 times r2. So by combining those formulas, we can start immediately with using the mass. So we don't have to convert the 20 gram into kilogram and then from kilogram have to go to Newton. We can just leave the gram in there. That is faster. So let's have a look at this question again. We can say, okay, we have now mass on one side, which is 20 gram, and we have a radius, which is 20 centimeter, and here we have mass that is unknown, and we have a radius that is 40 centimeter. Okay, so if we have that, let's take that to a new page. So we have the formula is m1 times r1 equals m2 times r2. We want to know m2, so m2 equals m1 times r1 divided by r2, which is 20 grams times 20 centimeters over 40 centimeters. 20 times 20, that's 400 grams centimeter divided by 40 centimeters. So m2 equals 10 grams. So a shortcut, I think that's much easier to do it like that. Question 40b, 39b is a little bit more difficult, because now they say you can't ignore the mass of the stick. And we have to calculate the mass of this one again. Now what do we know of the center of gravity of the stick? The stick is in total 60 centimeters. So the middle is 30 centimeters on the left, 30 centimeters on the right. So we know that this part is 10 centimeters. And 40 is then from here till here. The formula that we have now is the moment, so capital M on the left, is the same as the sum of the moments on the right. So M1 equals M2 plus M3. So let's fill in the data. We already know that we can use mass instead of force. So we can say lowercase m is 20 gram and the radius here is 20 centimeters. But now we have M2 and R2, that is this one. M2 is 10 grams and R2 is 10 centimeters. Now we call this one M3. We don't know, but we know R3, that is 40 centimeters. The formula that we have now is mass 1 times R1 equals to mass 2 times R2 plus mass 3 times R3. Let's fill in what we already know. 20 grams times 20 centimeters equals 10 grams times 10 centimeters plus M3 times 40 centimeters. We can already simplify that. 20 grams times 20 centimeters will be 400 grams centimeters. 10 times 10 is 100 grams centimeter plus M3 times 40 centimeters. So we have to apply the balance method that we've learned with mathematics last year. Now what we want to know? We want to know M3. Now what is annoying? Let's start with getting rid of this. So we can say, we start with swapping left and right side. So we have the M3 already on the left side. So we have 100 grams centimeter plus M3 times 40 centimeter equals 400 grams centimeter. So we didn't do anything special. We just swapped left and the right side of the equal sign. Now what is the most annoying now? Yeah, this is this one. So how do we get rid of it? You can see it's adding, so we can remove it by subtracting it. So we say M3 times 40 centimeters equals 400 grams centimeter minus 100 grams centimeter. Now that is 300 grams centimeter. The next thing that is annoying is the times 40 centimeters. It's multiplying, so we divide that. So we say M3 equals 300 grams centimeter divided by 40 centimeter. 300 divided by 40 equals 7.5 grams times centimeter divided by centimeter, so that is grams. So we know now that this fish is 7.5 grams. In question 40 we look at another mobile, 3 fish. luckily we can ignore the mass of the sticks again. Okay, we have to calculate the mass of fish A and B. Now, we can only calculate B if we know the force on this side of the mobile, but we can only know this side if we know mass of A. So we have to start with A, and when we know A, we can do B. So the first problem that we have to solve is we want to know A. Well, we know that this one is 10 grams. So divide it in left and right again. M1 equals R1 equals M2 equals R2 equals M1 we don't know. R1 is 20 centimeters. M2 is 10 grams and this one is 10 centimeter. Formula M1 times R1 equals M2 times R2. We want to know M1. M1 equals M2 times R2 over R of R1. So 10 grams for M2 times 10 centimeter divided by 20 centimeter. 10 times 10, 100 grams. Centimeter divided by 20 centimeter. 10 divided by 20 is 5 grams. You probably saw that already because you know this arm is twice the length of this arm, so the one on the right should be twice as heavy as the one on the left. It should be only half the weight of this one. So you can probably see already this 5 gram, but still you have to prove that using a formula. So we know this one is 5 gram. Now, if this one is 5 gram and this one 10 gram, then together they are 15 gram. So we can start a new problem. So we have M1 on the left is the unknown, but we know the radius is 50 centimeters. On the right we know M2 equals 15 grams and we know the radius is 20 centimeters. Again the same formula. It is a bit boring, isn't it? And now we want to know M1, so M1 equals M2 times R2 divided by R1, 15 grams times 20 centimeters over 50 centimeters. 15 times 20, 300 grams centimeter divided by 50 centimeter. So M1 equals 300 divided by 50 is 6 grams. So only 6 grams for B. You see, it's very simple if you do it step by step. First doing A. When you know A, you know that together they are 15 grams. 15 grams on a distance of 20 centimeters away. Now, 20 centimeters times 15 grams. And that divided by 50 centimeters. And you have 6 grams. Most All of the questions with levers are the same. Now let's have a look at an example with a pair of pliers. Okay, so what is that we want to know? Okay, this makes pliers exert 2 forces of 95 Newton on the wire. Okay, so the force here, force 1, equals 95 Newton, and this one we call F2. And you can see that the pliers have their fulcrum here, so we have a distance for F1 of 1.5 centimeters, and for F2 we have a distance of 9 centimeters. So this is R1 and this is R2. So F1 equals 95 Newton, R1 is 1.5 centimeters, F2 is unknown, that's the one that we have to calculate, and we know R2 equals 9.0 centimeters. So we use the standard formula for the lever, so that's F1 times R1 equals F2 times R2, and we want to know F2, so F2 equals F1 times R1 divided by R2. F1 is 95 Newton times 1.5 centimeters divided by 9.0 centimeters. (95 times 1.5 divided by 9 is 15.8. Always check if that makes sense. Does it make sense? 15.8 is smaller than 95, so that's why you use the pliers. If this was bigger, you wouldn't use the pliers, you would use your hand. So this looks like the right answer. (45) is a question about a nutcracker, and the difference between a nutcracker and the pliers that we just did is that in a nutcracker we have the fulcrum on the left side, so this is our fulcrum. Both forces are on the right side. That doesn't change anything. We still use the same law of levers. But the way they give your information here is a bit sneaky. So let's have a look. He exerts a force of 50 Newton on both handles. So here we say F2 equals 15 Newton. Why F2? Still the right side, F2. So here we have F1. Let's write the data under the picture. So we have here F1, that is unknown, and R1 is 4.0 centimeter. For F2 we know 15 Newton. And R2, and that is the snack. We have to know the distance from the force to the fulcrum. Now, that is first 4 centimeter and then 7.2. So the distance from here to here is 11.2 centimeters. 4 centimeters plus 7.2. Now, is it very difficult? No, it's just a little bit sneaky. If you don't pay attention, you think, okay, left is 4, and the right is 7.2. But that's not the case. If we know this, we can go on with the formula. Formula is again the same. F1 times R1 equals F2 times R2. We want to know F1. So F1 equals F2 times R2 divided by R1. So that is 15 Newton times 11.2 centimeters divided by 4.0 centimeters. So F1 15 times 11.2 divided by 4 is 42. 42 Newton is more than 15 Newton. That's why you are using the nutcracker and not your hand. So exactly the same, only pay attention. What is the distance to the fulcrum? So maybe first mark the place of the fulcrum, and then you won't be fooled by a question like this.